Welcome. In this video we are going to discuss how to graph a quadratic in vertex form. Vertex form of a quadratic is similar to the form that we saw with absolute value, where we have an a value in front. The a value in front determines a reflection of the graph, meaning the a value can tell you if the parabola is opening up or opening down. Okay, it can also tell you if it has a vertical stretch or shrink, which is a topic that you might not see much in Algebra 1, but you will revisit in Algebra 2. Okay, so if our a value is positive, then your parabola is going to open up. If your a value is negative, your parabola is going to open down. The h is where we will find our x value of the vertex. It also tells us if from the parent function, x squared, if there is a horizontal shift, and with that horizontal shift we can tell where the x value of the vertex is. The k value will tell you the y value of the vertex, which is essentially telling you if there was a vertical shift of the parabola and determines the y value of the vertex. So if from the parent function y equals x squared, the horizontal shift would move this vertex to the left or right, and a vertical shift would move the vertex up or down. In these first two examples, we're going to look at the vertex first. So you want to look at the value that's by the x in the parentheses, and then the value that is also outside the parentheses, which is your k value, or what's going to be the y value of your vertex. So this first one, I see what looks like a -1. Because the formula has a negative in it already, we know that the h value is 1, which looks like the opposite of what we see. The k value is 2. So the vertex is at 1, 2. I also want to note that your a value here is 2, which tells me that this parabola opens up like a cup. When we're looking at the next one, we see a +2 here, which tells me my h value is -2, and my k value, I'm going to keep the sign that I see. So -2, -1. Again, similar to what we did in absolute value functions. Our a value is -3, which tells us that our quadratic or parabola is going to open down like a frown. The most important step in graphing in vertex form is to identify the vertex, because once we know the vertex, we can easily use reflection over the axis of symmetry. So first I'm going to find the vertex. Remember, the vertex, we look by the x and we look by the y. Because this looks like a +2 in our formula, we want to make it a -2 for the x value of the vertex and a +1 for the y value. We're going to look at two numbers that are larger than -2 and two numbers that are smaller than -2. So if I was making my table, I would make this -1 and 0, and then -3 and -4. The nice thing about this is if we can find the y value at -1, it should match the y value at -3 because a parabola is symmetric over its vertex. Here, if I know the y value at 0, I should also know the y value at -4. So in order to do that, I'm going to look at substituting in -1. So I'll go -1 plus 2 squared plus 1. All I'm doing is looking at the equation that's written up here, and I'm replacing the x with the x value that I'm looking for. So if I have negative parentheses, -1 plus 2 squared, I'm going to evaluate this first, which is +1. But the negative outside turns it back to a negative. So -1 plus 1 is 0. If I know the value at -1, I should also know the value at -3. From here, I'm going to pick either 0 or -4 to substitute in next. I personally think it's easier to substitute in 0. So I put 0 where I see an x, and you could also type this part directly in your calculator if you're using one. So I would add the 2 first. 0 plus 2 is 2. We square the 2 to get 4, so -4 plus 1 is -3. That's the y value at 0 and also the y value at -4. When you go to graph this, I recommend graphing your vertex first at -2, 1. Then plot your other points. So -1, 0, -3, 0, -4, -3, and 0, -3. We want to make sure that this parabola is in fact symmetric and that our points do line up with each other. Okay, you also want to check things like, did I actually graph a U shape? Is my parabola crossing through the x-axis? Is it not crossing through the x-axis? We want to take note of these things as we graph. Okay, so I'm going to skip where we analyze all the characteristics because we have a video that does that. So if you need help answering these questions, please locate the video previous to this one about characteristics of a quadratic. I'm going to go ahead and graph another vertex form. So because I'm in vertex form, I look for my x value near the x in the parentheses. So I'm going to take the opposite. It looks like a -3. I'm going to make it a +3. The -8 I'm going to keep. I'm going to pick two numbers bigger than 3 and two numbers smaller than 3. Please note that these go directly in order. So you want numbers that go in exact order so that you can use symmetry across your vertex and axis of symmetry. So I'm going to substitute in 2 to begin. So 2 times 2 minus 3 squared minus 8. Again, inside the parentheses first, so -1 squared. -1 squared is 1. And then 2 times 1 is 2, so I get -6. That means the point at 2 is -6, and at 4 is -6. I'm also going to substitute in the number 1. 1 minus 3 first would be -2 squared. -2 squared is 4. 8 minus 8 is 0. So this value is 0 and this value is 0. I'm going to plot my vertex first down here at 3, -8. 2, -6. 4, -6. So those are my first two symmetric points. And then 1, 0 and 5, 0. Again, you should know where your vertex is. It should make a U shape. Also take note of your A value. We knew here that our A value was 2, so my parabola should be opening up. And in the previous example, we knew our A value was -1, so we knew that our parabola should be opening down. So those are other clues to make sure that you didn't make any mistakes when plotting the points for the graph.